2 minutes on the next thing, single slide story, making the point that you've already realized now in what I've shown you, that these probability distributions are all ready for us to play with in R, right? You have seen 2 of them very explicitly during the last examples. All of them comes in 4 different versions. Now we have the 3 ones, and there are many more, of course, but these are the 3 ones that I'm going to use with you in this course. The 3 discrete ones. Then we're going to have a few and a number of continuous ones coming up next week. These are the 3 discrete ones I will assume that you can work with. We have the density and we have the probability. So those 2, small f and capital F, are there explicitly for us to get the values from. Usually you would have to throw in either the p and the n and the lambda. You need to know the parameters, as we call it, or the unknowns in a way, of the probability function to work with it. You've also seen that for sort of teaching you probability, I thought it was very nice that we could simulate real experiments or real outcomes of random phenomena. We can simulate that on the computer by these R, the random number functions. That's pretty neat. It's a pretty neat thing to teach you probability, I think, apart from the risk that you get a bit confused about what is a computer thing and what is a real life thing. But anyway, I think it's neat. And in fact, in a few weeks from now, I'm also going to teach you how we can even more use such random number generations as a very, very strong statistical tool. We'll get to that. So the random number thing is not just a toy thing for me to teach you probability and for you to do dice throwing on the computer instead of real life. It's going to also be a strong computing tool for us. That is all some exciting things that is awaiting for us down the course. Finally, we have not seen this yet, and it'll be more used by us in the continuous world. It does exist in the discrete world also, but in the continuous world we're going to use it a lot. The inverse capital F function is also there. This is actually the so-called quantile function. We already discussed quantiles. So we'll get back to that. We're going to use that one later. If you are ever in doubt about how to use a function, both this function and any other function, write question mark binôme or p binôme. You didn't like that, so let's try p binôme. That's better. And then, of course, it's now very small for you, but then you get the help over here. And for all functions in R, if you go to the bottom, you will find working examples, sometimes more easily to cut and paste, or easily understandable than other times. But you can always find running examples that you can cut and paste into your own stuff to try things out, right? You cannot submit packages to CRAN, as it's called. You cannot make packages for people without also making running examples for people. So that's pretty neat. That was distributions in R. I have one more topic. As I said, we would go